Hello everyone, I am Gurpreet Kaur Khanuja. Today I am here to present on grid computing, unlocking the power of distributed resources. I am guided by my mentor Dr. Vivek Srivastava sir for this presentations. Let's explore how grid computing is reshaping how we utilizing computational power by distributing it across multiple resources. Grid computing is a revolutionary approach to computing that leverages the collective power of distributed resources, forming a virtual supercomputer. What is grid computing? To begin with, what exactly is grid computing? In simple terms, it is a technology that brings together computational resources from various locations to work on a single, often complex task. This distributed approach allows for substantial power and efficiency, which wouldn't be possible on a single machine. Grid computing harness a network of geographically dispersed computers, combining their processing power, storage capacity, and other resources to tackle complex tasks. It means we have a complex task and we dividing that complex task into simpler ones, and that these simpler tasks can be performed by different small machines, and different small machines output will recombine and form that one output of that complex task. It means it is the benefits of it is it is sharing resources. It allows for sharing of resources among different users and applications. Virtualized infrastructure, it means it's creating a virtual supercomputer by pooling resources from different machines. Scalability and flexibility, obviously if different machines are taking part, we can add new machines and remove new machines according to our needs, so it is flexible and scalable. Why is grid computing important? Exploring its benefit. Grid computing offers numerous benefits ranging from enhanced computational power to improved resource utilization. Increased performance is the first. It provides high performance computing by leveraging the collective power of multiple machines. It means the collective power of multiple machines increase our performance. Cost efficiency, but obvious, we are using our existing resource. We are not buying the supercomputer. Instead, we are doing our calculations by different small machines which are available to us and which is cost effective. Enhanced collaboration, it fosters collaboration by allowing researchers, business and institutions to share resources and expertise. Improved reliability, it increased reliability by distributing workloads across multiple machines, ensuring redundancy. Use cases of grid computing from research to business applications. Grid computing finds diverse applications in various fields, enabling complex computations, data analysis, and scientific discoveries. Scientific research, simulating complex phenomena, analyzing vast data sets, and accelerating scientific discoveries. In business applications, we can analyze our customer data, forecasting trends, and developing new products and services. In healthcare, we can use it for analyzing medical images, developing new drugs, personalizing healthcare treatments. Components of grid computing, key elements and its principles. Grid computing relies on a set of interconnected components to achieve its goal, enabling resource sharing, collaborative computing. The three major components are resource manager, middleware, and the application layer. In the resource manager is the one who manages and allocate resource within the grid. And the middleware provides a software infrastructure that facilitates communications and key data exchange. Application layer, it supports various applications that leverages the grid resources. How does grid computing work? The underlying mechanism. Grid computing operates by seamlessly integrating resources and enabling applications to utilize them as a unified system. Users submit task or application to the grid. The first one step is to the user submit task to app or application to the grid. Means I have a complex task, I am submitting it to the grid, and then the grid resources manager identifies suitable resource for the task. Means for that complex task, how many resources are required, and are these resources available or not? And then resources, if these resources are available, then it will allocate resources to the task. And the application executes across multiple nodes. Means if I have a complex task, it will allocate the resource manager will allocate the resource, and then on that resources my task will be executed in some smaller pieces and concurrently, and then results are collected from all the nodes or all the simpler tasks. We have each simple task has its own output. That output will be combined with another output and form the final output. Types of grid computing, variation and architecture. Grid computing encompasses different variations, each tailored to specific needs and application scenarios. The first one is data grid. In data grid, it focuses on sharing and managing large data sets across geographically dispersed resources. In what is computational grid? In computational grid, we have high performance computing task. In this, we have a computing task, and we have several machines, and then that machines we are performing small tasks of computations, and then combining that small computational task. In service grid, it offers services and resources as a shared infrastructure, and it enables collaborative work and resource sharing. AWS High Performance Computing HPC for grid computing. AWS HPC provides a robust and scalable infrastructure for grid computing, enabling users to leverage cloud resources for high performance computing. Elastic Compute Units is the first one, that AWS provides a wide range of virtual machines. We have EC2 machines, virtual machines in AWS, and it allows users to scale their grid computing resources. And storage solutions. In storage solution, AWS have various storage solutions like object storage, block storage, file storage, meeting the diverse need of grid computing applications. In networking, AWS provides high throughput networking, ensuring efficient data exchange among grid nodes. What are the challenges of grid computing? In grid computing, the security is hampered. Why the security is hampered? Because the task is divided into multiple nodes. In multiple nodes, the resources or our task is dividing, so our security is breaching. Sharing resources across a distributed network can expose system to security vulnerabilities. Resource management. In resource management, managing a grid with multiple autonomous resources can be a complex task. Network dependency. Performance is often limited by network speed and connectivity. If one network of one machine is slow, then other machines are waiting for the response to collectively give the final output. Heterogeneity. In heterogeneity, grid environment involves different types of hardware and software. We have already discussed it, that we have different machines, and if we have different machines, so we have different hardwares, and these hardwares are not compatible. So it's complex to make that compatible, that one output can be integrated with another output, and if they are not compatible, then how can we integrate it? The real world examples of this, the two projects are there: SETI@home and Folding@home. The SETI@home is project of Berkeley SETI Research Center. It is here to analyze radio signals with the aim of searching for signs of extraterrestrial intelligence, like aliens or different things. Until March 2020, it was run as an internet-based public volunteer computing project that employed the Boeing software platform. It is hosted by Space Science Laboratory at the University of California and Berkeley, and is one of the many activities undertaken as a part of worldwide SETI efforts. In that also, if my machine is free for some time, I have a simple machine, it is free for some time, I can use my machine to contribute at the project like SETI@home. That is extraterrestrial, that is for extraterrestrial activities, and it will do computational power for that project only. It's just like an open source project. In open source project, we contribute different machines, different people contribute on that one open source project. That's it is also just like that in SETI@home. Our machine is using our machine's power, our machine's memory, our machine's computational resources, our machine's processing power is using for that project only. In Folding@home, it is a project in which a distributed computing project aim at simulating protein folding to understand diseases like Alzheimer. In the main component is it's in this is Alzheimer. Alzheimer is a disease, and for Alzheimer, for detecting Alzheimer or for understanding the disease, we need to examine the protein structure. The protein structure can be examined by a supercomputer or it is a complex task. So to compute that complex, we need machines. So for that project, it is just like same as open source project Folding@home, and in this all the volunteers across different networks, means across the world there are different volunteers, and that volunteers are contributing at Folding@home in their free time. And in this, it is for disease research that simulate protein folding, computational drug design, and other type of molecular dynamics. As of today, the project is using the idle resource for personal computers owned by volunteers. All volunteers have their own personal computers from all over the world. Proteins are the elementary machine inside every cell that we rely on to keep us alive and healthy. So if we examine the structure of protein, we can easily detect our diseases and make it healthy and alive. The conclusion of my presentation is the future of grid computing and its implications. Grid computing is poised to play a pivotal role in the future of computing, driving innovation in various fields and enabling advancement in research, business, and society. First one is emerging technologies. The integration of AI, ML, and edge computing will further enhance the capabilities of grid computing. Increased adoption, grid computing is expected to become more accessible and widely adopted across various sectors, fostering collaboration and innovations. Solving global challenges. Grid computing can contribute to tackle global challenges such as climate change, disease outbreaks, and resource management. That's for all of today. Thank you so much, everyone.